Geometry 2.2 is dealing with logic, and basically in order to understand logic we're going to take a step away more from algebra and go into statements so you kind of understand the basics of logic before we apply it to actual math. And so in this particular section and next section we're going to be dealing with sentences. So first we need to know what a statement is, and if you've already done your vocabulary, a statement is basically a sentence that can either be true or false. There's nothing in the middle, there's no maybe, there's no, it can be both, so it's either true or it's false. For example, this statement here, Sacramento is a city in California. This sentence is true, okay? And but it's a true or false statement. There's not one or the other. It's not both, it's one or the other. And this P tells me that's a letter representation. You know how we use X to represent certain numbers? Well, in this case, we also use letters in order to represent these statements so that when we can write them in quick form. So that's the purpose of the letter representation. And this, whether it's true or false, is called the truth value. So Sacramento is a city in California the true value is true because Sacramento is indeed a city in California. The negation is the opposite. So I'm going to take my original statement, which is P, and put that squiggly line, and you read it not. So instead of saying P, I say not P. Okay? In this case, it's read, all I have to do is insert the word not into my sentence. So instead of Sacramento is a city in California, I put Sacramento is not a city in California. And usually the negation is the opposite of the statement. So this is false because originally our statement is true. Okay, without the word not, it's true, and with the word not in there, then it's false. So it's the opposite. So basically when we say negate or negation, we just have that squiggly line and you just insert the word not. So usually don't change the subject, don't change the sentence, just put not into it. Alright, don't forget to write this down and pause it. Okay, the next one here is a compound statement. So basically it's two or more statements that's put together. When we originally talked about Sacramento is not in California, we're talking about just one sentence. Here we're talking about two or more sentences that we're going to put together. And there's two different ways that we can put it together. So first let's start with two different statements. The first one, we're going to call that statement P. Sacramento is a city in California. That's what we've had before. The next one, the statement is Q. Sacramento is the capital of California. It's a whole different statement. Alright? When I have a conjunction, and it's this arrow, okay, it stands for the word and. So you see this term right here, and. Okay? So conjunction is basically you think the word and how I write it is P and then the arrow that goes up in Q. What this is telling me is I'm going to put P and Q together, and I'm going to connect them with the word and. Okay? So Sacramento is a city in California, and Sacramento is a city of California. This is true, and this is also true. So because both are true, the conjunction is true. If only one of this statement, let's say this is not true, then this would be false. Because in a conjunction, when you say and, both statements have to be connected together. I mean, both statements have to be true when they're connected together. The term disjunction is an upside down arrow pointing down, and it's joined by the word or. So instead of saying those two statements with and in the middle, a disjunction is saying those two statements with or. So Sacramento is a city in California, or Sacramento is the capital of California. So in order for this statement to be true, I just have to have one. So if one is false, it's okay. As long as at least one is true, okay, this or this can be true, making the whole statement true. So these are the symbols. Very important that you understand that. So conjunction has an up arrow and it stands for and a disjunction has a down arrow and stands for the word or. So we're just going ahead and connect those. So again, we have a compound statement. We either can have a conjunction with and a disjunction with or. Again, don't forget to pause and write down what we just went over. we're going to go over before going to our examples are called truth tables. So basically it's what we've been doing, except they don't actually give you a sentence here. You're going to use the logic without the sentence, because a true and false statement can either, a statement can either be true or false. Those are your only options. So, for example, I have, this is P is my original statement. Okay, we're going to talk about truth tables. So we're just talking about the true and false, the truth values of each sentence. So if I want a negation table, okay, I only have two options for my original. I can either have true or I can have false. Those are my only two options for my negation. So if the statement P is true, then its opposite has to be false. Does that make sense? For example, when we said Sacramento is the capital of California, that was true. So when I said Sacramento is not the capital of California, then it's false. Okay, so the negation has to be the opposite of the original. So if this is false, then this has to be true. That makes sense? So we're coming up with tables and we're just trying to discover the logic in it. Without the actual statement, we're just trying to figure out the logic in truth values. So for example, we have conjunction, all right? And instead of one, okay, I have a combination of two statements. Same thing with disjunction. This one I was only dealing with one statement. And one statement can either be true or it can be false, and those are your only options. But when you have two, okay, you have four options. Either they both can be true, or this can be true and this statement can be false, right? Or what are my other options? This one can be false and this one can be true. And my last one is this one is false and this one is false. Now this chart gets more if I have three statements, but right now I'm only working with two. So statement 1 and statement 2, statement P and statement Q. So I have a combination of four. They're both true. One is true and the other one's false. One is false and the other one's true, and they're both false. Now with that, I can discover the truth table for and. So with and, either both are true or the whole thing is false. What that means is this is true and this is true, so that means this whole thing is true. This is true and this is false, and again, they both have to be true. So if this one is true but this one's false, that means the whole statement is wrong because they both have to be true. The next one is this is false and this is true, but still, because one of them is false, this has to be false. And then finally, because they're both false, automatically that's false. So the only one of these statements that can be true is if both P and Q are true. Does that make sense? Let's try disjunction. Disjunction, we're dealing with two statements again. So let's see how this would work. We have, again, the same four combination, true, 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 false, false, true, and false, false. Okay? Now, in a disjunction, that's the down arrow. That stands for what phrase, and that's the phrase or. Okay? In the term or, unlike and, I just have to have one true. They don't both have to be true. At least one are true. If both of them are false, the whole thing is false. If both of them are true, at least one of them is true, then it's okay. For example, this is true and true. So this is in fact true because at least one. Even though both, at least one. This one is true and false, but I have at least one true, which is here. So this is still true. This one, false and true, I still have one true, so this is true. In this one, they're both false, so I don't even have one true, so this is false. So hopefully you understand exactly how to set up truth values. These ones are dependent on how many you have, and we're going to stick with two statements here. And then the last one is the one you fill out. Sometimes you're going to have more when you have negations, and we'll go over that in your example. So go ahead and pause this and write it down. Our first example, they're going to give us three different statements, and we have to write down what they want us to write down according to the statement. And then we're going to figure out if it's true or false. So first let's figure out if these individual ones are true. So AB is proper notation for segment AB. So that is how we write AB, so this is in fact true. This is centimeters are metric units, and this is in fact true. Meters are used as metric units. And 9 is a prime number. A prime number is basically a number that cannot be divided by 2. And since 9 divided by 2 gives us a decimal, this is also true. So we all originally start with true. So we're going to take the sentence Q, and the upside down arrow stands for which phrase? It stands for or, R. So I'm going to do centimeters are metric units, and then this term right here, or 9 is a prime number. Okay? Now the other one is a little bit tricky because it has this squiggly line, and this means what? That's negation. So basically, instead of writing Q, okay, I'm going to write not Q. So I'm going to write P, which is AB, is proper notation for segment AB. And this sign shows us and, so that term is and, the arrow pointing up. Centimeters are, and because it's the negation, I'm going to put the word not metric units. Right? So P, this is read P and not Q. So AB is proper notation for segment, that's P. The word and, not Q. Not centimeters are not metric units. So now let's try to find the truth value. Centimeters are metric units, and 9 is a prime number. Both of those are true, right? And we have the term or. So if at least one is true, the whole thing is in fact true. This last one, this one is true. AB is a proper notation for segment, but because segment AB, but because we have this not Q, and since the original Q is true, the not Q has to be false, okay? Making this false. So this is true and this is false, but since this is and, both of them have to be true in order to be true. So this is what? False. Go ahead and pause it and write down what we wrote down. And then for the assignment, make sure you do page 87, number 4 and 6. Our final example is constructing our own truth table. And for this table, we have not P and Q. Sorry, not P or Q, because it's a upside down arrow pointing down. So how many statements do we have here? We have statement P and statement Q. So let's start with that. We have statement P and statement Q. So what are our 4 options for if we have 2 statements? We have true, they both can be true. One true and the other is false. One's false and the other one's true. And they are both false. Those are our 4 options. But unlike our other truth table, this doesn't have, it's not just P or Q, but it's not P or Q. So we need to not figure out only P and Q, but we have to know the possibility of not P. Okay, because this is not P or Q. So if I look at P over here, let's just focus, let's ignore Q, because not P only works with this column. It has nothing to do with Q just yet. So it's the opposite. So if this P is true, then this one has to be false. And if this P is true, then this one has to be false. If this one is false, this has to be true. And if this one is false, then this is true. Alright? So now, when we have this statement, check. And we have this statement, check. Now we can put it all together to not P or Q. And what are the rules for or? At least how many? At least one has to be true. So they don't both have to be true, just at least one. So now we've already figured out what not P is. So we don't need this right now. We're just going to focus on Q and P, Q and column not P. Okay, because these are the two in our phrase. So as long as one of them is true, then the whole thing is true. So in this one, this and this, true and false, we have one true, so this is true. And this one is false and false, so because they're both false, the whole thing is false. This is true, they're both true, so we have at least one T, so they're both true. And this one is false and true, so they're both, so because one is true, then they're both true. And this is our truth table, the whole thing actually, but once we finish this column, once the last column looks exactly like your statement, then you're in fact done. So this one's a little bit more tricky, but go ahead and try page 88, number 12 in your book, and bring that with the other two back, and we'll figure it out tomorrow. Have a good day.